Welcome to Contract First API development using the OpenAPI Specification, formerly known as Swagger. Right. So this is Ian Zelikman. I'm Dave Forgac. You can read more about us on the bios on the OSCON site if you care. But the one thing I wanted to point out is that we're not affiliated with the OpenAPI initiative or the OpenAPI Spec. We're just users of the tool and fans of the technology. We have a lot of material to cover today, so I'm going to ask that you hold on to questions until the lesson periods or the break or the end. And then if you do have a question, just raise your hand at that time and I'll try to come around to you. All of the setup instructions and links to everything that we reference today are at betterapis.com, so bookmark this. I'm going to reference some URLs in some later slides. Don't worry about catching it at the time because they're linked from betterapis.com. If you haven't already set up the VM, you can go ahead and try to get started on that. It is a large download, so it might not finish during this first half. That's okay. We have a plan for that. But go ahead and at least try to get started on that. If you did set up the VM already, I'm going to ask you to do a couple things to make sure that you're up to date. We added a couple configurations to make part 2 a little easier. So in your repository that you cloned, make sure to do a git pull to get the latest updates. If the VM's already running, run vagrant suspend and then run vagrant reload -- provision. This is going to apply the latest updates from the repo so that everything works consistently in the second half today. And then after you do that, make sure you can log back in with Vagrant SSH. If you're getting prompted for a password when you Vagrant SSH, that means something's wrong with your SSH key. That's okay. We have set the password to just lowercase vagrant so you can get in for our purposes. So that's not secure at all, but it works for the VM for today. And then, like I said, we do have a backup plan. If you're not able to get the VM working during this first half, there is an online Swagger editor, and this will allow you to develop the spec in the browser and complete all the lessons in the first half, and then we'll try to get you up and running for the second half during the work time or during the breaks. So before we get started on the actual lessons, I want to go over just a little bit of background information to make sure we're all talking about the same things, using the same language. This will be a review for a lot of people, but there might be 1 or 2 new concepts for people, so I want to make sure we're all in the same place. REST is a huge topic. There are whole conferences on this idea of REST and RESTful APIs, so we're not going to cover all that today. But there's a couple things I do want you to know. REST is not a standard. It's an architectural style. And really what it is using HTTP for your service with a set of constraints applied. And if your service follows all of those constraints, then it is a fully RESTful service. Most of the time, though, we're not talking about fully RESTful services. We're talking about REST-like or REST-inspired APIs. And so that's really what we're talking about today. We're talking about HTTP APIs that follow some of the ideas from REST but aren't necessarily fully RESTful. So the typical things that they do follow are like mapping HTTP methods to actions, mapping URL paths to resources or objects. But it doesn't necessarily follow everything like hypermedia linking and some other topics that we're not going to go into today. There's this idea of an API contract. So the title was Contract First Development. So we should understand what that is. Like a legal contract, it's an agreement between 2 parties. So in this case, it's between the API consumer and the API provider. And it's best when this contract is negotiated. It includes an interface specification. So this is a technical description of how the requests and responses work. And then it also includes things like your service level agreement, terms of service, rate limiting, and things like that. Another thing we'll see a lot today is JSON. So JSON is JavaScript object notation. And it is a way to serialize data. So basically you take an object, you turn it into a string so that you can send it back and forth over the wire. There's another thing that we're going to be looking at today called JSON schema. And JSON schema is a specification for describing your JSON data. It is itself written in JSON. This is used in validation and in testing to make sure that the data being described in your JSON conforms to the format that you're expecting. Another thing we're going to be looking at is YAML. So it's another serialization format. It's a little more human readable than JSON. And it's actually a superset of JSON. So you're going to see in some places you have a YAML document, but a little section of it looks more like JSON, and that's allowed because the JSON is a subset of that YAML. And it has pretty broad language support, so it's gaining popularity for a lot of uses. So some just YAML really basics. When you're defining a list, you're going to have a key, colon, and then the list items are going to be indented and start with a dash and a space. And so if you have a long list, that's typically how you define it. Sometimes you'll see the shortcut, though, the second one, the colors and then the brackets. That describes the exact same list. You typically see that as a shorthand, though. So in the specs that we're going to be looking at today, in the examples, there are 1 or 2 places where the shorthand is used because there's only 1 or 2 items. Everywhere else, it uses the long format. Dictionaries are defined in a similar way. So you'll have the key, colon, and then the dictionary items are indented. So they're key value pairs, and you'll have the key, colon, and then the value. And then you can have free-form text in the YAML document, and there are 2 ways to control multi-line text. So in either one of these, where you would have the text, you use either a pipe or a greater than sign. And the only difference is the pipe preserves any new lines that are in the text, and the greater than ignores the new lines. And then we'll see that all of these structures can be nested together, and this is where you start describing a complex object. So the specification files we're developing today are going to be multi-level nested YAML objects. And you can see this is an equivalent JSON object and a YAML object, and you can see that the YAML is just easier for a human to work with. But these both represent the exact same thing. Okay, and now the topic of API definitions. If you've worked with like XML, RPC, or SOAP services, you might be familiar with WSDL. So this was a format that it's like XML, it's verbose, not fun to work with. When the JSON HTTP APIs started to become popular, a new definition format called WADL was developed. But like WSDL, it's XML, it's verbose, it's not fun to work with. So this new technology called Swagger was developed out of the kind of pain of WADL. And that's in the process of being renamed the OpenAPI Specification. But for our purposes today, the Swagger 2.0 is the exact same thing as OpenAPI Spec 2.0. So I'm probably going to go back and forth calling it both things. Just know that for now they're one and the same. There's a couple other formats. One's called API Blueprint. This is, instead of being in YAML or JSON, it's written in Markdown, but it does a lot of the same things. And it was developed by a company called Apiary that was recently acquired by Oracle. So it's not as open as the OpenAPI spec. And then another one is RAML. And RAML developed out of the early versions of Swagger from the perspective of modeling your APIs. The version 2.0 of Swagger that we're using today does a lot of the same things that RAML did, and version 3.0 is going to do the same. So the OpenAPI spec, like I said, it grew out of some frustration with WADL. So it was originally used via code annotations, so kind of the opposite of what we're doing today. You develop your implementation first, and the information about your API was embedded in the code, and you'd use a tool to generate the Swagger spec for the code in that direction. So today we're doing the opposite. We're developing the spec first. So originally it was JSON in version 1.0, and then when version 2.0 came out, they allowed you to use YAML for the authoring, and so a lot of the tools support YAML now. So this makes it a lot easier to do what we're doing today, which is build the spec first. Like I mentioned, the Swagger format is now under the OpenAPI initiative, which is a working group in the Linux Foundation. So there's an open development process. A lot of the big name companies that you know are involved, and so this is just a good open source technology. OpenAPI Spec version 3.0 is coming very soon. The release candidate 1 came out, I think, maybe 2 weeks ago, and the tooling will follow. So when 2.0 came out, there was a big lag between when the spec came out and when all the tooling supported it. 3.0 is a smaller change in the format, and because there's a lot of people working on it this time, the core tooling is going to be ready pretty much right away. Some third-party tools might have some lag time before they catch up, but I'd expect the 3.0 adoption to happen quick. Good news, we're developing in 2.0 today. There's already converters to convert your 2.0 spec to a 3.0 spec. So when the tooling is ready, if you've built up a 2.0 spec, you should just be able to convert it pretty simply. Okay, we're almost there. So a little bit about the tutorial today. It's split into 2 parts. So for part 1, we're going to define a basic specification for an API. And then in part 2, we're going to use that specification in a few different ways. We have more lessons than we expect to get through today for both parts. So don't worry when you see we're only through a few lessons from the end, but we don't get to the end. The point is you should be able to follow the rest of the lessons on your own afterward. So when we come back from the break for part 2, we're going to pick up right on part 2 so that we can get going with like the implementation and some things like that. So we have a few goals for today. One of them is to develop a basic OpenAPI specification for a simple API. We're going to show how you can do some testing and validation based on that spec. We're going to run a mock server so you can see what responses from an API that implements the spec would look like. We're going to develop a really basic implementation of the API, so we should have something simple that works. And we're going to generate documentation based on the spec. The repository that you should have a clone of by now is laid out like this. So there's the implementation directory. This is where the part 2 actual server is going to live. That's where you're going to be doing most of your work in part 2. But you can ignore that for part 1. The lessons has subdirectories for each one of the lessons we're going to go over. And each one of those have some examples that you can use to base your work on. And then if you're getting stuck or if you just want to check your work, there's also a solution file in each one of those directories that you can look at. If we get to the end of one of the lesson periods and you're still not done, we recommend just copy the solution file over into your working directory so we can proceed, and then we can look at what you got hung up on later. There's a presentation directory which has the slides that we're looking at right now. And then there's a work directory, and that's where you're going to do the bulk of your work for part 1. When you're running the VM, there is a synced folder. So the repository folder that you have cloned is mapped to the default user, which is Ubuntu's home directory, a subdirectory called tutorial repo. This allows you to use your own editor on your host machine for those files, or you can use tools on the VM for those files. There's some validators and some other things that are going to use the tools in the VM, but this allows you to edit from the outside too. If you have problems with that mapped folder, flag me down during one of the work periods. So for each one of the lessons, Ian's going to go over some instructions, give you some background information, So again, for part one, we're going to work in that work directory, use the editor of your choice, or the editor, the Swagger editor that he's going to show you. You're going to save a betterapis.yaml file, and then you're going to run a validator in the VM to make sure that the spec is valid. And then at the end, of each of the lessons, we'll just go over what you did. And again, if you get stuck, copy the solution file over, and you can get going. OK, so with that, we're going to actually start the tutorial. So Ian's going to take over.
OK, hello, everyone. I'm Ian. So as Dave said, we're going to do on part one, write the initial spec. And then in part two, we're going to see a few tools how you would use those spec. Just to gauge a little bit of the level, how many here have written a Swagger/OpenAPI spec before? OK, great. So so I say it was maybe around a quarter, a little bit less. If you, during this first part, it might be a little bit more easy for you. If you see in your vicinity people getting a little bit stuck, would appreciate if you help them a little bit. We'll try to also walk around and help people. So now we can start. So this first lesson, we're going to explore a little bit the environment, the initial tool you have in the VM, looking at some OpenAPI spec examples, and exercise the tool a little bit. If you have the VM clone, well, have the repo cloned and the VM started, you should be able to go to your localhost port 8000 and be able to see a Swagger editor there. If you're editing stuff locally with your local editor the way you like, you'll be able to SSH to the VM and run Swagger validator and see if your spec is valid or not. So let me jump in and show this a little bit. So this is what you should be seeing if you have the VM running. Should be going to port 8000. And then if you open the Swagger editor, you probably will be doing like importing files the way Dave mentioned. You'll be looking at the lessons and perhaps seeing some of the examples we have there, or the solution if you haven't reached it by the end of the time we have for the lesson. So for example, if we go here, we import the YAML, and we have the example for basically lesson 2. Also, you can see some of the examples that come in with the Swagger editor. So you can see here the default example, and you can see an example of a Swagger spec that is valid and describes like an Uber API. And you can see a brief example with it. You can use those examples to reference as you go along and to check if you have any validation errors. So for this for the first lesson, what we're going to do is you exercise a little bit the Swagger editor, load up port 8000, or if you have it installed locally, it might be on a different port, and also go to the lesson 1.01, and there are a few broken examples there with the Swagger editor, so you can practice a little bit the YAML syntax Dave talked about, and try to fix those examples to have them as a valid Swagger. I think this will be a good time if you have any problems setting up your VM or any initial installs. Let us know. We'll come by. We'll try to help out and figure out. So we'll give about 5 to 10 minutes for people to work on this. We'll see how fast people finish that. I hope everyone had a chance to finish it up. There were, as you've probably seen, some small syntax errors with those files, like a missing colon and the missing spaces, stuff like that. So hope everyone are YAML experts now, and we can go to the next part. So in this part, we just want to see a basic API, OpenAPI spec. We'll see both a YAML and a JSON example of those. And we'll try to start our working example based on like incremental steps for this. So go here. So you can see here a first example, a very basic example of a Swagger a spec. What you can see here, it starts with the Swagger object, and you have basically a bunch of objects through your document. The Swagger 2.0, and as Dave mentioned, this is quickly will change to 3.0 basically as the new spec goes out. Then you have a bunch of metadata with the host, base path. You have the info that also contains a lot of metadata about your spec. And then you optionally can give schemes and which meme types are consumed and produced by your API spec. And then you also, at the very end, you can see here you have the basically empty paths. So the parts that are mandatory to put in are basically this Swagger directive, and then you have to put info, and I believe only the mandatory one is the title. Other parts are optional. And then even if you're putting an empty element, it still has to be an empty element of paths. So this is something that might trip you up in the beginning, where if you're doing a very basic implementation that doesn't really require functionality yet, you might not want to put the paths in, but that one is required, but even it has to be empty like this. If you go see now, I want to show additional example where you can see this. An example of the JSON file, which is basically the same spec, but using JSON. You can see it much less readable with a bunch of curly braces and things like that. And that's why there was a tendency to move over to YAML for the readability part. And then if you need for some reason, then it's very easy to convert the YAML into JSON if you have some tools that are actually, you need those to read the JSON one. So we saw these two examples. And then for this exercise, we're going to start building our working example. Basically, what we're going to do is work on a spec for a conference we're calling Better APIs. And you would incrementally build the functionality into your spec, basically for your contract API. So for the very first part, you would just define your Better API spec. Put some metadata into it. You need to make all the required parts that I mentioned. And feel free to put any optional stuff there. Put the paths as empty for now. And basically you'll move from there. And then feel free to be as creative as you like with the metadata, with hosts, and stuff like that. OK, so I think most of people probably have it working, maybe on their way to have a valid spec. Here you saw that basically, if you looked at the solution in your solution directory for the lesson, you might have seen metadata a little bit different, but the important part that you have a valid spec. Right now already you have basically a valid spec, a valid contract with your clients. Right now you still don't have functionality in it, and these are the parts we're going to add in the next few lessons. So now we want to start with actually doing the basic part for our functionality, and for that we'll start with setting up paths for it. So how do we define the basic path? Here you can see an example of the path object. You see /paths, and underneath you have this one is basically relative to the base path that you might have indicated in your API spec at the very top layer of the spec. And then inside of the path object, you have an operation object, which is in this case is a get. This is where we actually define the logic inside of the action. And it also holds some metadata, as you can see, for example, summary and description. And then the action can also hold the responses. And the responses, as you can see, have nested the response codes in them. For example, here is a 201 with the description, OK, basically. The responses and the actions can also have optional headers and a body, and we can see how we're defining those parts. But this is a basic example of like a very simple base path that you would define. So we want to practice that a little bit. So obviously for the Better API conference, we want to define two basic endpoints, which would be the talks and the speakers. And we want to define them at this point just to support gets and return basic status of 200 OK. Very similar. If you're getting stuck, let us know, or you can look at the solution, or at first reference the example that you have in your folder for the lesson. Okay, I think we had about 10-15 minutes for this. We're going to go to the next lesson. So here we defined the very basic spec with our paths, and now we want to add some more functionality into it. So now basically we want to define more complex operations for us to support into our paths. So if we look here in this paths object, now we can look at the post, which will be more complex. You can see the parameters. This is what is driving the operation, and this is the data that is being passed as an array. Here you'll see the name is Pat, the important keyword here in body, and that also can be the parameter is passed in a path or in a header query or in a form. Then there is a description of the parameter, and then it's being described with the schema, which is the JSON draft version 4, I think, of the JSON schema that Dave mentioned before. And the data types, you can see there, for example, here it's type string for the name. Those can be basic types like integers or longs, bytes. And also one type that's not defined in the JSON schema is a file, which specifically defined with the Swagger. And as I mentioned, the schema object is the JSON schema specification draft 4. And you can see each of the attributes, for example, here the name, it also has attributes such as description, and you can also put some more like a title pattern, and you can even define stuff more complex like minimum and maximum length for your parameters that you're passing over. If we continue looking at our action here, we also define a more complex response now. With the 201 response code, we're seeing, as we saw before, the description. But now we also see that the response actually returns back the path ID. And the path ID is basically a number. And we can also give it a more description for our clients to say that this is a unique ID that is returned from our action. So now we can have more complete functionality that is described both from the request that is coming into our path and also a more complete response that we can return back to our client. One thing I want to mention is that the response object, besides the description and the schema, there is also optional fields that you can add here, which is the headers, an array of headers, and also an array of examples that you can add to your responses, and we'll see examples of that going forward. So this one also is going to be a little bit more complex, I think, lesson or exercise. So we would add the actions to support speaker registration and being able to submit a talk through our API. And you're free to define those speaker and talk object any way you choose. You can define more complex fields or just stay with one or two fields in your object. Okay, so I hope everyone had at least a chance to get almost complete this lesson or finish it completely. I want to point out, if you looked at the solution, you might have seen for some properties some basically additional information, additional properties you can put on those attributes. The read-only is kind of interesting in the Swagger spec, where that gives you the ability to basically specify that this is an attribute on the object that's only passed in the response, but it is not expected that your client is going to pass that in the request. And that can be something helpful, specifically with, as you've seen for this kind of spec, if you've been following the solutions that you have in your folders. And also the format is going to give you a little bit more fine-tuning of the attributes versus just using those basic base parameters. So now we're going to go to a lesson that I think that was one important for us to use, which we call the Minimalist API. And here we're going to see how you actually, now you're seeing that a lot of what you're doing might be repetitive with how you're defining your spec. So now you would see how you can actually reuse some definition, reuse some of the things you did, and not to be as repetitive, and really how the Swagger spec enables you to be effective with your time. So first of all, we'll see an example of the path parameter for completeness. So this is how you would define a path parameter, and the only difference from probably what you saw before is that now the in keyword is specifying that it is in path, and then all the names for the path ID, as you've seen in the path, and the name for the parameter, they need to match in order for the tools that are working on your Swagger spec to be able to identify them correctly. And now you'll see how you can actually reuse some of the definitions that you have seen, that you have basically made. So if you're defining a parameter of a path ID, you would see how you might need to reuse it on basically different endpoints. So you also have an array in the root of your Swagger spec, which is optionally you put parameters. So you actually defined your parameter here instead of inside of the action, and you put it in parameters path ID, and you do this whole definition for the parameter. Now, usually on top of it, you would have somewhere in the spec, in the endpoint, you actually define the parameters, and you're using the ref keyword to reference your path ID. And you can see how you can do this on basically multiple endpoints and don't have to redefine the same path ID every time. And then if at some point you actually change that, like you change the type from a number to a string, you're not going to do it in one place and then forget to do it in a bunch of other endpoints the way you wanted to. The same thing you defined for more general objects, where you're defining a definition of your path object, and you can see here required the name status, and then a bunch of properties for it, and a bunch of other data. But then you're also not just reusing it inside of the endpoint, as you can see on top in the schema. You're actually, if you have an array with the items of a path, you're just reusing this, and you're saying paths is basically an array based on the type that I've just defined here. So it really keeps you much more of a dry and being able to just define it once and then keep it much more consistent. And I think this gives you the idea of what you do in this exercise, where you would take your API that you have done so far and refactor your objects to be defined as in those definitions and in the parameters, and then reuse them in your endpoints, and update what you have done before. And we split this into two parts. So once you've done this refactor, you would add the two new paths, the speaker ID, and the talk ID, and define the additional CRUD operations for them in order to be able to delete and update your talks and speakers. So I recommend you try finishing up that part one, and then move over once you have a valid passing spec, do part two, which would require a little bit more time working on it.
Okay, so it's 10:28. We have a break at 10:30. So I know people are still working on this. You can keep working on it. Or if you want to go take a break, you can go do that now. And so we're going to start back up at 11 with part two. If you have any questions or wanted help getting your VM set up in the break, flag me down and I'll still be walking around.